So remember, definite integrals are where they have a set limit or a set range that we're looking at, a domain between an x equals a and an x equals b. On your screen you can see that the integral of fx dx is the antiderivative of b minus the antiderivative of a. Now remember, the antiderivative is the reverse of differentiation. So we will cover that in some of the examples to just remind you how to do that. But essentially what this does, it finds the area under a set range in the curve. So if you look at the example there, that diagram, you can see between A and B, the shaded green color is the area we will find using this method. So here we have a definite integral, and what we need to do first is find the antiderivative. So we need to find the antiderivative. So remember, in this case, I'm going to do square brackets so we see what's going on. Our 2x, the power needs to go up by 1. The 2 out the front remains, and we get a fraction out the front for the new power. So we get x squared. The 1 turns into just an x. Now, once we've done this, we need to still include our a and our b so we know what's going on. So we know 3 goes there and 1 goes there. All right. So now what we need to do is find our fb minus our fa, where b is here and a is there. But before we do that, I'll actually simplify. Actually, let's do this. I will simplify this, which I should have done first. 2 times a half is just 1, so we get x squared plus x, 3, 1. All right, and now we can continue. So what I'm going to do is I'm going to substitute in my 3, so we get 3 squared plus 3 minus our substituted 1 value, so 1 squared plus 1. You can put that in your calculator and you end up with 10. So we'll do another one to get your head around it again. So we find our antiderivative first. So x5 becomes x6 with a 1 over 6 out the front. Like that. We can simplify that down. So this becomes x6 over 6, 2 minus 2. Now we can do our substitutions. So for the first one, we get 2 to the power of 6 over 6 minus 2 to the power of 6 over 6. You can put that in the calculator and you end up with 0. Okay, so if you're starting to see the pattern here, we find the antiderivative, and then for our 2 limits that we have, our a and our b value, we substitute those in, and it's b take away a. So the antiderivative of b take away the antiderivative of a. So we'll do another one here. So we need to find the antiderivative. Alright, so before we even begin that, can I simplify that down? Yes, I can, so let's do that before we even think about doing the antiderivative. One of the x's cancel here, and I'm left with 3 dx, and now I can find the antiderivative. So I get 5 remains out the front. The new power becomes a 4, so 1 over 4 x to the power of 4, and then we get 3, 1. So we can simplify this down now. We get 5 x to the power of 4 over 4, 3, 1. And now we can do our substitutions. So again, we do our focus on our 3 first. So we get 5 times 3 to the power of 4 over 4. Alright, so that one comes first here. Then we focus on our a value, so we get minus 5 times 1 to the power of 4 over 4. At this point you can put it into the calculator and you get 100. Now we'll look at something that comes across a little bit more often. So we got velocity function and we need to find the displacement between 2 and 4 seconds. Alright, so we need to convert this into a definite integral. We know it's between 2 and 4, and the lower number will be our a, so a equals 2 and b equals 4. So I can write that we're trying to find the integral between 2 and 4 of 3t squared plus 7, and then because we're dealing with t's here rather than x's, instead of writing dx at the end, we write dt. Alright, now we do the same thing we've been doing this whole time. We find the antiderivative, so we get 3, because it's out the front it stays, plus 7t square, and then 4, 2. We look at simplifying where we can. These essentially cancel out, so we're left with t to the power of 3 plus 7t, like that. Now we're focusing on the 4 first, so we get 4 to the power of 3 plus 7 times 4. We then focus on our 2, and we get 2 to the power of 3 plus 7 times 2. You can use a calculator to solve it, and we get 70. Now it was displacement. Displacement is distance, so our units are meters. So there we go. So to recap the video, remember you do have an area enclosed by a curve where you're trying to find the area between the lines x equals a and x equals b, and those are just some set limits we've set. And what you do is you find the antiderivative first. Once you found that, you substitute your a and b values into the antiderivative and find the difference between the antiderivative of b and the antiderivative of a.